Hi, welcome to this video as part of the higher maths straight line topic, looking at how to find the gradient given an angle. The two things you want to be able to do from this video is to be able to calculate a gradient given the angle to the horizontal and to be able to calculate the angle given the gradient. First thing we're going to do is just have a quick look at a wee situation here. So we're looking to find the gradient of this line. Now we already know that to find the gradient of the line it's going to be the y2 minus y1 over x2 minus x1, or the vertical divided by that horizontal. Now what we're going to change here is rather than just having points, or rather than just being able to see the size of the vertical and the size of the horizontal, we're going to be given an angle here with a horizontal instead. Now with that angle now in play, actually we don't really call this the vertical anymore, because we've got the angle there. We know that's going to be the opposite. Okay, and we don't call this the horizontal anymore. We call that the adjacent. Excuse me, sorry. Okay, now the gradient is vertical over horizontal, but it's not vertical anymore, it's opposite. And when it's not horizontal anymore, it's the adjacent. Now we know opposite over adjacent is tan of the angle that's given there, so tan of theta. Okay, now what that means is if we have that angle there, we know that the gradient is equal to opposite over adjacent. So the gradient is equal to tan theta as long as we have that angle, with the horizontal there. Now the place you're most likely going to be given that angle is the x-axis, because it's an existing horizontal line that's on your graphs. So if you want to find the gradient, the new formula we have is tan of that angle. And there's a wee note for you. Okay, and then we'll look at some examples after you've copied that. Okay, so here we're looking to calculate the gradient of the line shown. Okay, so here if we want to find the gradient, it's tan of theta. So it's just tan of 27, which when you type it into your calculator gives you 0.509 and so on. So let's call it 0.51. So the gradient of that line there is 0.51. For the second example here, slightly different. Going back to your note, remember we need to ensure that the angle has to be on the positive side of our line. So here, this 68 degrees is on the left hand side, so it's not good for us because we know the gradient there is going to be negative, and tan of 68 will not give us a negative answer because it's still in our first quadrant. So we need our positive side of the line there. Now if that's 68 degrees because it's a straight line, we know this has to be 112 degrees, and the gradient there is tan of theta. So tan of 112, so tan of 112, which is negative 2.475. Let's just call it negative 2.5. Okay, now it is as easy as that. We're going to use it in different situations, and there may be kind of tricky things on top of that added in the kind of problem solving aspect of it, but it's as easy as that. So looking at question 2, find the angle that the line PQ and the line joining P and Q makes with the positive direction of the x-axis. Okay, and this is slightly different here in that we are looking for the angle now. Okay, so we're not looking for the gradient, we're looking for the angle. And we know that the angle is involved in this equation, m is equal to tan theta. So if we want the gradient, we need the angle. Alternatively, if we need the angle, we need the gradient. Okay, and we know there from PQ, we can use our y2 and y1, x2 minus x1. So that's x and y, that's x and y. 1, 1, 2, 2. So it's going to be 7 subtract negative 2 over 1 subtract negative 2. So that's 9 over 3, so that's just going to be 3. So we know the gradient is 3 from these 2 points. So 3 has to be equal to tan theta. So if we want to know theta, we're going to do the inverse tan of 3. Tan inverse of 3, which means our angle is 71.6 degrees. Okay, so that's working with the gradient to work backwards to get the angle there. Okay, that's us. Any issues, ask your teacher. Thank you very much.